Hello, Year 11s, Mr. Miller here. Hope that you're doing well. I'm going to be going through model answers to the 2017 Paper 1, which is a non-calculator. Before you do this, it's really important that, first of all, you have completed the paper. There's not much point you going through this video if you haven't tried any of the questions yet. So please spend at least 90 minutes trying the paper first before watching this video. It's also worth you having a look at the mark scheme. You may want to just tick the questions that you've got correct, and you don't have to bother watching the video, and you can only watch the video for the questions that you got wrong. So look at the mark scheme. It's in the same folder as this video. After the paper, have a look at the topics you struggled with and go to Corporate Maths to practice those, and then try the questions that you struggled with next week. All right, let's get started with the paper. I'm going to do it as if I haven't seen the paper before. All right, so question 1, I can see it's a scatter graph question, which is great. Let's have a look at the first question. So one of the points is an outlier, write down the coordinates. Okay, nice and easy start. I'm going to circle that point, and I can see it as 10 and 19. For all the other points, write down the type of correlation. That is obviously positive because my line of best fit, which I'm probably going to draw in a moment, is upward sloping. Okay, on the same day, the maximum temperature was 16.4, and it says estimate the number of hours. So I know that I always have to draw a line of best fit. I'm going to do it without a ruler. You guys should use a ruler because mine is messy. Please use a ruler in the exam. I'm then going to go up from 16.4. So 16.4 is my maximum temperature. So it is here. I'm going to go across to my scatter graph, very messy without a ruler, and down, and I've got 13 hours. The mark scheme gives a bit of leeway, but I've got 13 hours. If you've got a bit more, a bit less than that, it's great. Weatherman says, temperatures are high on days when there's more sunshine. Does the scatter graph support your answer? So temperature is higher on days where there's more sunshine. I think I'm going to say yes, because I can see that as the hours of sunshine increases, maximum temperature also increases. Great, nice and easy start. Let's move on. Okay, question 2, nice, easy question. So prime factor tree, 7 and 8, circle 7 its prime, 2 and 4, circle 2, 2 and 2, and we're going to write it as 2 times 2 times 2 times 7. We've done this a million times in do nows, so it's a nice and easy 2 marks. That shouldn't take you much time. Question 3. Okay, so I got a decimal calculation. So 54.6 times by 4.3. The first thing I'm going to do before I do any calculations is work out an estimate for this. So roughly what's it going to be? Well, 50 times by 4, let me just write down estimate. I'm not actually going to do this, but just to check that my answer is going to be right. So 50 times by 4 is 200. And I'm expecting a little bit more than 200 to be my answer. A little bit more to be my answer. Okay, so what am I actually going to do? I'm going to do 546 times by 43, and then I'm going to need to move back my decimal point. So 546 times by 43. Let's do it. 6 times 3 is 18, carry the 1. 4 times 3 is 12, plus the 1 is 3. 5 times 3 is 15, plus the 1 is 16. 0 is my placeholder. 6 times 4, 24. 4 times 4 is 16, plus the 2 is 8. And then 5 times 4 is 20, plus the 1 is 21. Add these together, 8, 7, 4, 3, 2. So let's write down those digits. 2, 3, 4, 7, 8. But because I went back 1, 2 decimal places, I'm going to have to go back 1, 2 decimal places. So this is my answer. Is it close to my prediction? I said it was going to be a bit more than 200, which it is. So I feel pretty confident that I got those 3 marks. Let's move on. Okay, The area of square ABCD is 10 centimeters squared. Show that 8x squared plus 6x equals 1. Okay, so if it's a show that question, I know that this needs to be my answer. I do not want to start off with it. Okay, so I need to find that as my answer. So I know in the question it talks about area, and it is, so it equals 10. Okay, I think I see where my equation is going to be. Let's find out the area of this shape. So 3 times 3 is 9. 3 times x is 3x. I got 3x here, and I've got x squared here. Great. So now let's collect like terms. X squared plus 3x plus 3x plus 9 equals 10. X squared plus 6x plus 9 equals 10. And I want to get to x squared plus 6x equals 1. So can you see how to do that? I think if I just minus 9, I've got x squared plus 6x equals 1. And that's it, I'm done. Nice and straightforward. Easy start to the paper, I think. Hopefully you've all got full marks so far. Okay, next question. I got a frame made from 5 straight pieces of metal. And I'm told the weight of the metal is 1 kilogram per meter. Okay, so I think I need to work out the length of all 5 pieces of rod. Let's just check that there are 5. 1, 2, 3, 4, 5. Yeah, okay. So I've got the length of 2 of them. And I think the length of the one on the top is also 12 meters, and this one on the side is 5 meters. But what about the one in the middle? Well, I think the clue here is this right-angled triangle. So it is Pythagoras, I think. So let's call this x, and let's do 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. 169 equals x squared, and the square root of 169 we should know is 13. So this is 13 meters. So using that, let's find the total length. So that was step 1. Step 2, the total length. Well, that's just going to be 5 plus 5 plus 12 plus 12 plus 13. So that's 10 plus 24, 34, which is 47 meters. And now the weight of the metal is 1.5 kilogram per meter. So for each meter, the weight is 1.5. So step 3, find the weight. So I'm going to do 47 times by 1.5. Okay, let's just do a calculation off to the side. So 47 times by 15. Okay, so it is 5017. So that is going to be 70.5. And I'll put my units, which is kilogram, might be a mark for the units. Okay, let's move on to the next one. Okay, this one I got an equation of 2 lines. Show that these 2 lines are parallel. Okay, so to show that they're parallel, I've got to show that they've got the same gradient. So let's have a look. Line 1, y equals 3x minus 2. Well, this is already in the form y equals mx plus c. So 3 there, my gradient is 3. So that's nice and easy. But line 2, let's write that again. This is not in the form y equals mx plus c. So I need to rearrange to make y the subject of the equation. So let's get the plus 5 to the other side. And now let's get the 9x minus 9x to the other side. 3y equals 9x minus 5. And then finally divide by 3. Got to remember to divide everything by 3 here, so that is 3x minus 5 over 3. And as I was expecting, this gradient is also 3. So I probably need a concluding sentence. So as the gradients are the same, as the gradients are equal or the same. The lines are parallel. Fantastic. Okay, next question. All right, there are 20 boys and 10 boys and 20 girls in a class. Class has a test. The mean mark for all the class is 60. So I'm looking at mean in this question. And for all the class, so that is all 30 people, the mean is 60. And I'm told the mean mark for the girls is 54. And I want to work out the mean mark for the boys. Okay, so whenever I'm doing mean, I'm going to put my results in a table. So I know, let's just remind myself, the mean is the total number of marks, so the total number divided by the number of pieces of data. So let's put all of this in a table. So I've got the boys, I've got the girls, and then the whole class. And I've got the number of pieces of data. I've got the total number of marks, and I've got the mean. So I've got the mean here, total number. All right, so let's see what I've got here. So 10 boys and 20 girls. So 10 boys, 20 girls, 30 in total. And I'm also told the mean mark for the whole class, which is 60. Okay, so if I'm told the mean mark for the whole class, to find the total number of marks, I'm going to do 30 times by 60, which is 1,800. So that's the total number of marks. And then for the girls, the mean is 54. So again, I'm going to multiply. And 54 times by 2 is 108. So that's 1080. So therefore, I can find out the total number of marks for the boys by just doing a subtraction. I can do this in my head. I think that is 720. So to find the mean for the boys, I'm going to do 720 divided by 10, which is 72. So that is my answer. I can write that on the answer line. And that also makes sense, right? If the mean for the total is 60 and the girls is lower, then obviously the mean for the boys is going to have to be higher to make up for that. So let's move on. All right, so next question, standard form. So firstly, I need to write something as an ordinary number. So I know how to do this. I'm going to write up my number. And then because my power is negative, I need to go back 6 decimal places. So 1, 2, 3, 4, 5, 6. And I'm going to put zeros for my placeholder. And I'm going to rewrite it on the answer line 0.000000797. Okay, next question. Work out the value. All right, so it's a division here. So I'm going to have to do, first of all, 2.52 divided by 4. And then I'm going to have to do 10 to the power of 5 divided by 10 to the power of minus 3. So let's do the power of 10s first. So that's easier. I think that is 10 to the power of 8. Because when I divide, I subtract my powers. So 5 subtract negative 3. It's the same as 5 add 3, which is 8. But then I got this division, which I have to do, which is a bit annoying. But I think that if I do 252 divided by 4, so I can do a bus stop here. So 4s into 25s go 6 times, remainder 1, 63. So that is going to be 0.63 times 10 to the power of 8. Now this is not in standard form, of course, because my first number needs to be more than 1. So I'm going to times this one by 10, and then I have to divide this one by 10. So 6.3 times 10 to the power of 7. Let me write that on my answer line here. And this is very common for them to ask you standard form questions in a non-calculator paper. So it's really important, if you're not confident, you go onto Corbett Maths, you do lots of problems when you have to divide, multiply, add, and subtract. So that is that question there. Okay, Jules buys a washing machine, 20% of that is added, so it's going to make it more expensive to the price of the washing machine. Jules then has to pay a total of 600. Okay, so this is after the VAT is added. So I think this is a original and new percentage question. And he then has to pay 600, so I think 600 is my new. And my scale factor, well, a 20% increase, that means times by 1.2. So to get my original, I'm going to have to divide by 1.2. Again, another decimal division, so we really have to be confident with this. Let's do it this way. So 600 divided by 1.2. And then another way to divide by decimals is to get rid of the decimal. So times it both by 10, 6,000 over 12. And then let's just do another bus stop here. So I know that 12 goes into 65 times. So my original is 500. So let's write that on the answer line there. And that makes sense because my original has to be smaller than my new if I'm increasing by a percentage. Let's move on. Okay, so show that x plus 1, x plus 2, x plus 2 can be written in the form. Okay, so pretty standard expanding triple brackets question. We'll do x plus 1 times by x plus 2 first. So we should be pretty confident with this. This is x squared plus 3x plus 2. And then I'm going to set up 3 by 2. So I've got my x squared, 3x and 2. And then I need to multiply that by x plus 3. So let's do that now. 2x, 3x squared, 9x, and 6. And now I just need to collect like terms. So it is x cubed plus 6x squared plus 11x plus 6. And yeah, it's in the form that I wanted, so I am done. So quite an easy one there because there were no negative numbers there. So fine. Okay, I got a graph here. Let's have a look. So write down the coordinates of the turning point. Okay, so the turning point is here, which is where the graph turns. So that is 1 minus 3. Write down estimates for the roots. Okay, so I've got to remember what the roots are. So the roots are where it hits the x-axis here. So circle it here and here. So my roots are going to be x is about 2.7, the first one. So call that x1. And then the second one is going to be minus 0.7. Just reading off the graph. Use the graph to find an estimate for f of 1.5. Okay, what that basically means is that if I plug in, because it's y equals f of x, so I need to plug in x is equal to 1.5. So when x is 1.5, let's find 1.5, which is here. I need to go down to my graph, which is here, and then across, and then read off this value here, which I think is minus 2.8. So that is my answer, y equals minus 2.8. So you need to remember what a turning point is, what a root is, and then the third question, just need to think, okay, what am I asked, what am I given? Well, I'm given f of 1.5, so f of x, so read off my y value. Let's move on. Okay, question 12. Nice, we've got some indices questions here, so it should be quite a nice 4 marks to get. So I got a negative power. So negative means I take the reciprocal of 81, which is 1 over 81, and then the power becomes positive. If I'm raising something to a power of a half, that is the same as square rooting. So square root of 1 is 1, square root of 81 is 9. So that's my answer, 1/9. And then the third one, okay, so got a power of 2 over 3. So first thing I need to look at is my denominator. So that means I need to cube root. So you should know your cube root. So cube root of 64 is 4. Cube root of 125 is 5, but then I need to remember to square it. 4 times 4 is 16, 5 times 5 is 25. So that's my answer. Good, let's keep going. Okay, got a table here with some x and y values. Y is inversely proportional, inversely proportional to the square of x. Find an equation for y in terms of x. Okay, so proportion question, y equals, well, inversely proportional, I need to remember that my k is on top, and then I've got a fraction, the square of x, so x squared. So I need to find out what my k is, and to do this, I need to look at my table. So actually, I can choose any of my values of x and y. It's always going to work. So let's just pick one without the fraction. So let's pick this one here. So x equals 1, y equals 9. Sub it in. 9 equals k over 1 squared. So 1 squared is just 1. So k is equal to 9. So I need to write the equation now. So y equals k, which was 9, over x squared. Find the positive value of x. Okay, interesting. Positive value of x when y is 16. All right, so I think I need to rewrite this equation. 16 equals 9 over x squared. And I need to solve this equation. So I'm going to multiply by the denominator. So I've got 16x squared equals 9. Divide by 16. So let's continue my working up here. X squared equals 9 over 16. And then I'm square rooting. So the square root is 3 over 4. Why does it say positive value? Well, that's because if I square root something, it can also be a negative number. But I don't want this one because it has to be positive. So I'm going to put my answer line, x equals 3/4. And I'm going to cross there because it has to be positive. Nice, let's keep going. Okay, let's move on. Right, lots of words here, so I'm not going to be scared. Let's just go through the question and then annotate as we go. So white shapes and black shapes are using a game. Okay, so I've got white shapes, let's just call that W, and black shapes B. Some of the shapes are circles, all right, let's draw a little circle, and all the other shapes are squares. Let's draw a little square there. All right, the ratio of the number of white shapes and the number of black shapes is 3 to 7. Okay, let's just write that down. So white to black is 3 to 7. Okay, let's give that a tick there. The ratio of number of white circles to the number of white squares is 4 to 5. Okay, and the ratio of number of black circles to number of black squares is 2 to 5. Work out what fractions of all the shapes are circles. Okay, so I can split this ratio. I've seen this kind of problem before, I think, where if I look at my white shapes, I'm actually going to rewrite this as white to black as 3/10 and 7/10. Because if I turn it into a fraction, this is going to help me a lot with this kind of question. Okay. So what about number of white circles to white squares? So if I just look at the white shapes, the ones that are circles versus squares is 4/9. So 4/9 of the white shapes are circles, and then 5/9 are squares. And then black shapes will do the same thing. So that's going to be 2/7 are black circles, 5/7 are black squares. And I want all the shapes which are circles. So I want this and this. So how am I going to do that? Well, let's have a look at white circles. So for white circles, it is 4/9 of 3/10. So 4/9 times 3/10, which is 12 over 90. And I can do the same thing with the black shapes as well. So this is going to be 2/7 of 7/10, which is 14 over 70. So if I add these two fractions together, I will come up with my answer. So I'm going to do this working up here. 12 over 90 plus 14 over 70. Probably makes sense to simplify this first. Let's simplify up here. So divide by 2, 6 over 45. And then divide by 3 is 2/15. And this is going to be 7 over 35, which is a fifth. So that's a lot easier. 2/15 plus 1/5. That's nice and easy. 5/15, which is a third. So that is my answer, a third. Write that there. Okay, so we've seen that kind of question before in class. And when you see a problem like this, you need to turn it into a fraction. So a fraction of a fraction. Turn it from a ratio into a fraction. So pretty tough one here, but it is question 14. So let's keep going to the next one. Okay, next question. So I've got a cone here, volume of a cone. So volume of the cone is 98. So let's write that down. Volume is 98 and radius r is 5.13. Okay, work out an estimate for the height of the cone. So as soon as I see this word estimate, especially on a non-calculator paper, I'm immediately thinking I need to round. Okay, so let's think what would be sensible to round. Well, I think my volume rounds up nicely to 100 and my radius rounds nicely to 5. So I'm going to use those. I've rounded both of them to one significant figure. Okay, so let's use my volume of my cone. So volume equals a third pi r squared h. Now we're going to substitute in my numbers. So my volume is 100. I got a third. Now, okay, pi. I've actually forgot about the pi, but because pi is equal to 3.1415, blah, 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 I have to round my pi as well. So I think it makes sense to round my pi to 3, to the nearest significant figure. So pi is 3. Now, what's my r squared? I said that my radius I would round to 5. And then I need to find out my height. Okay, so let's solve this equation. Well, a third of 3 is just 1, so I can cross that out. I've got 100 equals 25h. And then that gives me a nice answer for my height, which is 4. So let's write that on my number line, 4. Okay. John uses a calculator to work out the height of the cone. Will your estimate be more than John's answer or less? Okay, so a bit of a tricky one here. Let's actually write out my formula again and figure out for my estimate, what have I done? So I rounded up my volume for my estimate from 98 to 100. I also rounded down my pi and I rounded down my radius. Rounded down my pi and I rounded my radius down from 5.13 to 5. So what does that mean for my estimate? I think that for my estimate, to make this balanced, my height is going to have to be higher. So I'm going to say my estimate is higher. Therefore, well, that's it. My estimate is higher. And I probably need to write a bit of an explanation. Since I rounded volume up and pi and radius down. So a bit of a tricky one, but if I think about going back to the question, what have I done? I should come to a sensible conclusion, just for 1 mark there. Okay, n is an integer greater than 1. Prove algebraically that n squared minus 2 minus n minus 2 squared is always an even number. Okay, so if we're looking to prove that something is an even number, then it means that it's a multiple of 2. So my aim is to get a multiple of 2, so 2 outside of brackets. All right, what do I need to do here? Let's first of all expand this out. So n minus 2 squared. N minus 2, n minus 2. And we'll do this. Nice and easy. So we've got n squared minus 4n plus 4. All right, so now let's simplify everything. So n squared minus 2 minus brackets, that's important. So what does that equal to? That's n squared minus 2. Now I need to be careful here. So minus n squared, but it is plus 4n because it's a negative times a negative, which gives me a positive, and then minus 4 because it is negative times a positive. You can imagine there's a secret 1 outside the brackets. So when we're multiplying it out, it looks like this. All right, let's simplify that. So I got n squared minus n squared. That cancels out. And I got 4n. I got minus 2 minus 4. So that is minus 6. And that's good news because I can factorize that to get 2 outside the brackets. And I just need to make a statement. So anything multiplied by 2 is an even number. Anything multiplied by 2 is an even number. Great. So 4 marks there. Should have been pretty straightforward as long as you didn't make a mistake with the brackets there or the collecting like terms. Let's move on. All right, there are 9 counters in the bag. 7 are green, 2 are blue. Okay, this looks like a probability question. Oh yeah, work out the probability. So I think this is a pretty standard probability tree diagram. But I just need to make sure that, okay, it takes at random 2 counters. So she's going to take one, but it doesn't say she's going to put it back. So you have to assume she takes one, doesn't put it back, and then takes another. So it's a little bit trickier. So on the first pick, it's easy. Green and blue. So 7/9 and 2/9. But then on the second pick, I need to be a bit careful. So if she picks a green, then let's just draw it out. So I've got 7 green. 1, 2, 3, 4, 5, 6, 7, and 2 blues. So if I first pick a green one, what have I got left? Well, there's 6 green left and 8 in total. But if I pick a blue one, if I pick a green one, then blue is 2 out of 8. Okay. But if I pick a blue one first, let's cross out a blue one. Then there's still 7 green left, so 7 out of 8, and 1 blue, 1 out of 8. All right, let's do my outcomes, which I can do. And I want one of each color. So which of those? I think it's these 2 outcomes here. So I'm just going to work out the probability for those. 7/9 times 2/8, 14/72. And then 2/9 times 7/8, 14/72. And I'm going to add them together to get 28/72. It doesn't say simplify, so I don't need to simplify. I can just leave my answer like that. So we've done lots of those kind of questions in class this year, so hopefully you found that easy. The mistake that you could have made there is, I think, thinking that you still had 9 counters in the second pick, but you're picking 2 at the same time, so you don't replace them. Let's move on. Doing well. All right, this looks like a more challenging question. So ABCD is a rhombus. All right, that's going to be important, a rhombus. The coordinates of A are 5, 11. So let's add that to the diagram, 5, 11. 5, 11. Okay, the equation of the diagonal DB is y equals half x plus 6. So let's add on a line here. This equation here is y equals half x plus 6. Find the equation of the diagonal of AC. So let's draw on this line. All right, so equation of diagonal. So it's obviously a straight line. So my answer needs to be y equals mx plus c. And I already know a point on this diagonal. So I know this point 5, 11. How am I going to find the gradient? Well, something that you need to remember about a rhombus is that its diagonals meet at a right angle. So actually, these 2 diagonals are perpendicular to each other. So I'm going to find the negative reciprocal of a half, which is minus 2/1. So my gradient, m, is minus 2. And I also know that x is 5 and y is 11 for my coordinate. So let's substitute that in. 11 equals minus 2 times by 5 plus c. 11 equals minus 10 plus c. Add 10 to both sides. C equals 21. So I can write in my equation y equals minus 2x plus 21. And that kind of makes sense because I can see that this line AC is downward sloping. So it's got to have a negative gradient. And its y-intercept also has to be positive. So I'm happy with my answer. So a bit of a tricky question that became a lot easier once you annotated the question and then you realized you can even, if you're not sure it's a right angle, it's probably a good guess that it's a right angle. But once we had all that, it became a lot easier. So let's move on. Okay, next question. All right, it's a vector question here. So let's have a look at it. So I've got a parallelogram here with O to A is A. So I'm just going to write in A there and C there. It might be useful later, might not, but we'll have a look. X is the midpoint of AC. Okay, so let's draw in this line AC, and let's put X somewhere in the middle there. OCD is a straight line such that OC to CD is K to 1. All right, so I got another point here that I need to put on, which is a point D. It's going to be somewhere along this straight line OCD, but I don't really know where. So let's just put it here for now. And I'm told that X to D is 3C minus a half A. Okay, so let's figure out what I need to do here. I think my first step is I need to find a vector for X to D. And I'm going to get there by doing, I think, X to C and then C to D. Okay, so X to C, I think, is easy. So my next step, I'm going to get, first of all, I know what A to C is. So that's going to be minus A plus C. Therefore, X to C is X is the midpoint of AC, so I'm going to half that. So minus a half A plus a half C. Great. So I made a good start. Probably already got a mark or two here, which is good. But now I need to find what C to D is. So what am I told? I'm told that OC to CD, I'm just going to write K to 1 underneath that. I'm told that in the question. And I also know what O to C is, which is the vector C. So actually, it looks a bit weird here, but I think what I'm going to have to do is I'm going to have to find my scale factor from K to C. So times by, how do I get from K to C? Well, times by C over K. So the vector CD is actually C over K, which looks a bit weird, but that's what it is. So now I know what X to C is, and I know what C to D is, and I also know that X to D is equal to 3C minus a half A, and that is equal to, well, X to C is minus a half A plus a half C, and then C to D is this thing C over K. All right, so what do we notice? Well, first of all, I notice that I've got minus a half A here and minus a half A here, so that's good. So I'm going to kind of tick that. That's good. But now I need to compare my C coefficients. So on the left-hand side, I got 3C. I'm just going to continue it up here. So comparing my coefficients of C. So I got 3C equals a half C. And I'm actually going to write C over K as 1 over K lots of C. Maybe you'll see why I've done that. Well, I've done that because now, if I just highlight my C's, I can compare the coefficients. So 3 is a half plus 1 over k. And now I've got an equation with just k in it, and I can ignore the c's because I'm comparing the coefficients. Right, so let's subtract a half from both sides. So 3 minus a half is 2.5, or 5 over 2, which is 1 over k. And now I'm going to cross multiply. So writing it over here, running out of space a bit. So 5k equals 2, and then k is equal to 2/5. So that was actually a really nice, nasty vector question. But you do see these quite a lot where you have to kind of compare the coefficients so that you're ending up with finding a value of an unknown. So maybe it's worth practicing some of those on Corbett Maths because those are quite tricky. And I think we will have a revision lesson before the next mocks on vectors because it is one of the hardest topics. But let's move on. Okay, next question. Solve algebraically the simultaneous equations. Okay, this is good. I know how to do this. We're actually going to do a revision lesson on this because when this comes up, it's worth a lot of marks and it's a process that we can just learn what to do. So in case you don't remember, the first thing I need to do is I need to take my linear equation and I'm going to make y the subject. So add 3x to both sides. Y equals 3x plus 13. And now I'm going to rewrite my quadratic, the one with the squares, and I'm going to substitute in my y. So I get an equation with x only. So x squared plus 3x plus 13 squared equals 25. So just to get my highlighter out so you can see where that's come from. So instead of the y, I substituted in my expression that I got earlier. So now this is a quadratic in terms of x only. So I need to expand all this out. So do it here. 3x, 13, 3x, 13. So 9x squared, 39x, 39x, 169. So that is 9x squared plus 78x plus 169. So x squared plus 9x squared plus 78x plus 169 equals 25. Add together the x squareds. And as we know, I need to make everything on one side equal 0. So minus 25 from both sides. Good. Okay. So I'm going to have to factorize this, but before I do that, let's just see if I can make this any easier. So I'm actually going to divide by 2 to get my terms a bit smaller. So it should be a bit nicer. All right. So I need to factorize this. I'm going to do it up here. So 5x squared. This might be a bit of a nasty one actually. Plus 72 equals 0. So I need two numbers that multiply to make 5 times 72. 5 times 72. Okay, 72 to go over here. Times by 5 is 360. So multiply to make 360 and add to make 39. Gosh, this is actually a really nasty one, but I got time, so I can actually work through all my possible factor pairs of 360. So if I pick an obvious one, let's try 36 and 10. Does that add to make 39? No. So it's not going to be this one. But actually, if I keep on going, and I actually had to re-record this and find out my factor pairs, I found it. It's actually 24 and 15. So those add together to make 39. So a bit of a nasty one, but I got there in the end. Okay, so now I know what to do. So 5x squared plus 24x plus 15x plus 72 equals 0. So just to show you what I did there, I took my x term and I split it using those two numbers that I had. and then I'm now going to factorize. So dash line down the middle, take out an x here, 5x plus 24, and I can take out, what can I take out here? So I think I can take out a 3x here, or just a 3, not a 3x, just a 3. 5x plus 3 into 72 goes 24 times. And actually, I'm really happy to see that because I got 5x plus 24 on both sides. So that's good news for us. Okay, so x plus 3 times by 5x plus 24 equals 0. So what are my two solutions? So x1 equals minus 3. So that's easy. But then here I've got 5x plus 24 equals 0. So it's going to be a nasty one. Minus 24, minus 24. 5x equals minus 24. So x2 equals minus 24 over 5. All right, so I found my x values, but I've got one more thing to do. I'm going to find my y values. So let's do that in this final box here. Not much space for this, quite a lot of working. All right, so x1 equals minus 3. So my y1, I'm going to substitute in minus 3 into my expression for y, which was 3x plus 13. So y1 is minus 9 plus 13. y1 equals 4. But if I got x2 equals minus 24 over 5, y2, so let's do the same thing. 3 times by minus 24 over 5 plus 13. Minus 72 over 5. And let's put 13 as something over 5. 13 times by 5 is 65, I think. Yep. And then I think I'm almost there. What's that going to be? Minus 7 over 5. All right, so I've got my answer. That took a lot of work, but it's towards the end of the paper. And it was some quite difficult algebra, but we got there in the end. It's definitely worth practicing this. Let's just write out my answer. So x1 is minus 3, x2 was minus 24 over 5, and then we had y1 equals minus 20, sorry, y1 equals 4, minus 4, and y2 was minus 7 over 5. All right, so quite a lot of work to do, but as long as you get started with it, you're going to pick up lots of marks and then keep on going through the algebra. Let's move on. 2 more questions to do. Okay, 2 questions to go. So ABCD is a quadrilateral. AB equals CD. Yeah, I can see that on the diagram. And ABC equals angle BCD. Okay, prove that AC equals BD. Okay, so it's a proof question. So let's just write in these sides A to C. That's A to C. And B to D. So I want to prove that these 2 sides are equal. So what kind of proof question is this? Well, I think I've actually made 2 triangles. So I think this is a, let's just think, I think this is a congruent triangle proof, which is good because we've done a lot of that this year. So let's highlight my 2 triangles. So first one is A, B, and C. And then my second one, B, C, D. So I think if I can prove that these 2 triangles are congruent, so let's just write this down. If I can prove that ABC and BCD are congruent, then it means that those triangles are exactly the same, therefore AC equals BD. So let's have a look and see how I can prove that these 2 triangles are congruent. So what sides or angles do I have in, that are the same? Well, let's start off with BC. So I think BC is a shared side. So let's start off side. BC is shared. Okay, do I have an angle here? Well, yeah, I've got an angle here. I've got this angle here and this angle here. And they're the same. So ABC equals BCD, and the reason given in the question. So I need one more side or angle, and I think it is this one here, AB and CD. So side AB equals CD given in the question. So I can ready draw my own conclusion. Therefore, ABC and BCD are congruent due to side angle side. Therefore, AC equals BD. So actually, it was a really quite an easy congruent triangle proof, but I think the difficulty is realizing that you needed a congruent triangle, needed to do a congruent triangle proof. And I think I did that because I drew in my lines first of all, and then I identified that, okay, I made two triangles, so therefore, because I need to prove something, it's probably a congruent triangle proof. Good, let's move on to the last question. Okay, final question. Now you might actually recognize this because I put this as a final question on one of your year 10 half-term assessments. And I think I remember telling you at the time this is a horrible question that originally took me about 20 minutes to work out. So if you're stuck on this, then I sympathize with you because it's very tricky. But I'm going to show you how to do it. I'm going to show you what clues there are in the question that can help you work this out. So I've got this hexagon. And I've got ABEF and CBED are congruent parallelograms where AB equals BC equals X. Okay, I don't have anything written in on the diagram, so let's write that in. AB, BC are X. Okay, P is the point on AF, and Q is a point on CD, such that BP equals BQ equals 10. All right, so let's draw in some lines here. So BP and BQ are both 10. All right, given that ABC is 30, okay, so ABC, it's this whole angle there, which is 30 degrees. Prove that cos PBQ equals 1 minus something x squared. Now that looks really, really horrible. But actually, I'm going to stop and think for a second. I see this thing cos here. And when I see cos, I'm immediately thinking of the cosine rule. The cosine rule. And I'm especially thinking that because I think I might be able to form some triangles here in the question. And I know that I use the cosine rule with triangles. So let's remind myself, what is the cosine rule? A squared equals B squared plus C squared minus 2BC cos A. And now let's actually think about what triangles I have here. So let's have a look at triangle ABC. I'm just going to draw a triangle ABC up here. ABC. So I've got ABC is that angle there is 30. I know that. And I know I've got X and I've got X. But I don't know what AC is. Okay, but that's actually not my only triangle because I've also got this other triangle, which is PBQ. So PBQ. So I know my side lengths here, 10 and 10, but I actually don't know this angle here. So I'm going to call this angle theta. Now, I've got this other length of my triangle, AC and PQ. I don't know what it is, but I know it's the same in both. Because if I just change a different color, I've got A to C, and that is exactly the same as P to Q. So I'm going to call that Y on both of them. All right, now I don't know exactly where this is going, but I thought I'm going to use a cosine rule. So let's use the cosine rule on triangle ABC. So ABC, what have I got? Let's just mark on these side lengths. So A is the side that's opposite the angle BC, and then that's my big angle A. I do the same thing while I'm at it with triangle PBQ, so big A, small a opposite B and C. Okay, so let's do the cosine rule on ABC. So A squared, that's Y squared, equals B squared, so X squared, plus X squared, minus 2X, X, cos A. And I know that A is 30, so I should write cos 30. Let's get rid of that A and write 30. And I know that cos 30 is root 3 over 2. That's one of my exact trig values I have to remember. So let's simplify this. I've got y squared equals 2x squared minus, now, 2 times x times root 3 over 2. Well, 2 times root 3 over 2 is just root 3 because the 2's cancel out. So I've got x squared root 3. Okay, so let's leave that for now. Let's now look at triangle PBQ, and we'll do the cosine rule again. So what have I got? I've got y squared again equals 10 squared plus 10 squared minus 2 times 10 is 10 times cos theta. All right, so that's y squared equals 100 plus 100, 200, minus 2 times 10 times 10, so that's 200 cos theta, cos theta. All right, let's look back at my question again, and I want to prove that cos PBQ. Well, what is PBQ? Well, PBQ is just theta. So instead of theta here, I'm going to write cos PBQ. Okay, so I want to make cos PBQ the subject here. So I'm going to rearrange this equation. I'm going to add 200 cos PBQ to both sides because I want to make that positive. So 200 cos PBQ plus y squared equals 200, and then let's minus y squared. Minus y squared, 200 cos PBQ equals 200 minus y squared, and then finally divide by 200. So cos PBQ, well, 200 divided by 200 is 1. 1 minus y squared, or sorry, 1 minus y squared over 200. So actually, I reckon if I take stock and look at where I'm up to, that was not a good idea to highlight with that. Get rid of that. If I highlight what I'm up to, I'm actually really close to my answer. Because my answer has cos PBQ equals 1 minus, but instead of y squared, I've got something to do with x. So I'm actually almost there. I'm going to continue my working around here. So I'm going to write cos PBQ equals 1 minus, well, what is y squared? Let's go back to equation 1, which I haven't used yet. So equation 1 is here. So what is y squared? Well, y squared is 2x squared minus x squared root 3 over 200. And I need to put this in brackets there. And I'm almost there, actually. I actually just need to do one more step of my working, which is 1 minus, and it looks like my 2 minus root 3 are in brackets, because I can factorize out an x squared over 200. Okay, so that is actually it. I've done that. As I said, that took me a good 20 minutes to figure out how to do. So don't be too worried if you're looking at this and being like, oh my god, I could never do this. Well, actually, you can, and definitely you could get some marks for getting some of the way there. But I will reassure you that I think very few people who actually took this exam back in 2017 got any marks for this. So they often put a really tricky question on the last question. Don't worry too much about it, but it is good to show you these questions. And actually, if you followed the steps, then you've done a really good job. Okay, so that's it for the paper. So on reflection, I actually think the start of the paper, the first 14, 15 questions were actually quite accessible. So hopefully did quite well on them. And then it got quite tricky, the last 4 or 5 questions. There was that vector question, there was the quadratic simultaneous equation question, and then that really nasty question at the end. But hopefully you would have felt quite comfortable with the first sort of 2/3 of that paper. So what's next for you? So this should get you thinking, like, what am I going to revise before the February mocks? And I think there's some pretty clear questions that came out of this one. The first is, like, obviously that vector question was quite tricky. So you might want to go back through some of your notes from vectors and try some questions from Corbett Maths, and also quadratic simultaneous equations. We haven't done this in a while. It always carries lots of marks, and it's usually quite a nice, accessible question. But you might have also struggled with some other things. So it's really worth you going on to Corbett and practicing those questions. And there are the answers on Corbett, but of course you can always come to me with some extra help if you're not sure. So thanks very much for watching. Hope this was useful. Please let me know if you found this useful. Give me some feedback. What was good? What could be better? It's my first one of this, so hope it was useful. Hope it was worth my time, and hope you got a lot out of it. Thanks very much. Have a good rest of your weekend. Bye bye.